Hello children, now here we have come to the concluding part of the chapter force and pressure, and our last topic is fluid pressure. Before that we must discuss what is fluids. Fluids, anything which can flow are known as fluids. So liquid and gases are example of it because they used to flow. Now in case of gases, the molecules are very loosely packed within the gas, so they can flow in random direction. But in case of liquid, a liquid always flow from a higher level to a lower level. So fluid pressure is what? The pressure exerted by fluid is termed as fluid pressure. The expression of it is also pressure is force by area. So, in fluid pressure, our first topic will be buoyancy. What is buoyancy? Buoyancy is a phenomenon that whenever a body is immersed in a liquid, buoyancy. Whenever a body is immersed in a liquid apply an upward force. That force is known as upthrust or buoyant force, and this phenomenon is known as buoyancy. That means we'll define it. Whenever a body is immersed in a liquid, it experiences an upward force known as upthrust, and this phenomenon is termed as buoyancy. This upward force is just like the normal reaction for a solid. So we'll see one practical application with this, and my humble request that you please try to do it today in your house also. Please come to me. Now here I have taken some water in a bucket and I am pouring this open area in downward direction, and what I am experiencing, just you please try to see. I am applying the force in downward direction, and at the same time I am experiencing that the liquid is applying force in upward direction. As I am leaving it, it is just coming upward. If further I am tying it again moving it in upward direction. That upward force I am experiencing is the buoyant force, and this phenomenon is termed as buoyancy. Now, this buoyant force or the buoyancy depends upon many factors. So our next topic will be the factors governing the buoyancy or buoyant force. Factors affecting buoyant force. With the expression of force F equal to mg that we have discussed in this chapter only. So force is m into g, where m is the mass of the body and g is the gravity of the earth, if you are talking about the earth. Now m, we will see that by which the force is applied on the body. It is applied by the liquid. So as much mass it is applying the force in downward direction, the liquid also try to exert force in upward direction, which apply this mass. So we'll correlate this mass with the density of that liquid. So we are knowing density is mass by volume. Here volume of that liquid. So mass we can replace by the product of density and volume. In place of this mass, we'll substitute the value there. So the expression for buoyant force F, B I am writing B बोले तो buoyant force. So it's the density D plus volume V and G is the gravity. So the factors affecting buoyant force are density of the liquid, V volume of that liquid and G gravity. That means these all are directly proportional to the force applied. That's why so many cases we talk about that why the ice used to flow on water, on the other hand nail used to sink on water. The answer will be the density of this ice is less than the density of water. That's why ice used to flow. On the other hand, the density of the iron is very much more with respect to water, so iron sinks. Also, you can tell yourself why a dead body used to float in water and a living body sinks in water. We can conclude that the density of dead body is smaller than the water, so a dead body floats. On the other hand, the density of a living body is much more higher than the density of water, so living body sinks. Now we'll move to the atmospheric pressure. Atmospheric pressure. That buoyancy is the force due to the fluid, but generally we have restricted there for the liquid. But in case of atmospheric pressure, we will not consider the liquid, but we will consider the gases. So how we define atmospheric pressure? The pressure exerted by the air column on the surface of Earth is termed as atmospheric pressure. We have a blanket of air around us. That air is applying pressure in our downward direction, and that pressure is atmospheric pressure. So as we'll go to the upward direction, that means we'll go towards mountain or we'll go above the mountain, the atmospheric pressure get reduces, and that's why we suffer from so many problems due to going in high altitude. So atmospheric pressure is what? The pressure exerted by the air towards the surface of Earth, is termed as atmospheric pressure. Generally, the expression of atmospheric pressure near to the surface of Earth is 1.01 into 10 to the power 5 Pascal. Is it required to ask what is Pascal? That is the SI unit of pressure. So in this video, I have prepared up to this much only. You please try to do practice of this topic. I will try to upload one more video. There I will go for some application of buoyancy and expression for the pressure exerted on a liquid column. My humble request, you please go through these things, and whatever doubt you are facing, if anywhere, feel free to send me your feedback on my WhatsApp number. Thank you.